Welcome to my channel. My name is Kidana Madam. Today I will show you how to fix units, how to draw grid lines, how to define material, how to define section property for a 8-story mixed-use building located in Addis Ababa, Ethiopia. Okay guys, subscribe to be updated for all my video. Let's start. First, you have to open ETABS 2060. ETABS 2060 is in the process of opening. Okay. So click on New Model. New Model initialization box is coming. From here, we have three options. That is use saved user default setting. This is a default setting from ETABS. And the second option is that use setting from a model file, that is from defined model before. And the third choice is that use built-in setting. This is by putting any setting or by selecting any code or doing everything in ourselves. For example, display unit. In Ethiopia, you have to use a metric SI unit system, a steel section database. For our building, we have not used a steel section, but you can make it error code because of Ethiopian building code of standard is similar with that of European norm. A steel design code. This is for reinforcement bar. You can use also European code or European norm. Concrete design code. For concrete design code also error code 2004, that is European code. Make it okay. From here grid line initialization box is coming. So number of grid line in X direction, number of grid line in Y direction, spacing of grid in X direction. Okay, we have to show architectural plan to fill this data. So the architectural plan consists of a basement floor with parking purpose and ground floor for different shops, and first floor typical second to fifth floor for apartment purpose, and terrace floor. Elevation and sections of this building looks like this. So number of grid lines in X direction means that 1, you can count it simply, 1, 2, 3, 4, 5. And number of grid lines in Y direction is that 1, 2, 3, 4, 5, 6. You can fill this data on ETABS. Number of grid line in X direction, that is 5. Number of grid line in Y direction, that is 6. A spacing of grid in X direction and spacing of grid in Y direction, you can pass it, and you can edit it further. So grid level. Okay, beginning of XID and beginning of YID. Okay, go to architectural plan and you can check. Beginning of XID is in alphabet manner, and beginning of YID is in a numeric manner, and it's from top to bottom, and that of YID is from left to right. Okay, first you have to close other projects. Okay, so beginning of XID is in alphabet manner, and it's from left to right. That is okay. And beginning of YID is a numeric, and it's from top to bottom. Make it okay. And grid spacing data. Grid spacing data is used to edit our grid. Okay, make it click. Okay, edit grid. So we have two choices, that is display grid data as ordinate and display grid data as spacing. Make it display grid data as spacing because it's simple to edit. So the distance, okay, in x spacing, the spacing between A to B is 8, B to C is 8, as you have to take a default. So you have edit it using the architectural plan. So the distance or the spacing between A to B is 4.4. The spacing between A to B is 4.4. Okay. Make it 4.4. And the spacing between B to C, the spacing between B to C, 5.3. Okay, make it 5.3. And the spacing between C to D, the spacing between C to D, 4.55. Make it 4.55. And the last spacing, that is between D to E, 5.3. Make it 5.3. Okay. Then you have to go to Y. That is the spacing between 1 to 2. I think it is 6 meters. The spacing between 1 to 2, 6 meters. Okay, that's good. 1 to 2. Make it 6. And the spacing between 2 to 3. The spacing between 2 to 3, 3.85. Make it 3.85. And the spacing between 3 to 4. The spacing between 3 to 4, 5.45. 5.45. And spacing between 4 to 5. The spacing between 4 to 5, that is 5.4. 5.4. And the last spacing, that is between 5 to 6. Okay, 2.9. So make it 2.9. Okay. Story data. Number of story. That means total number of story in our building and typical story height. Okay, I will show this terms on architectural plan. Okay, go to the section view. So number of story. Number of story means total number of story, that is the sum of basement floor, ground floor, first floor, second floor, third floor, fifth floor, roof terrace, and water tanker. So simply we can count it. So total number of story is 1, 2, 3, 4, 5, 6, 7, 8, 9. Total number of story is 9. And typical story height. This is the distance between each story. So you can measure, for example, from first to ground, 3.2, and from first to second, it's 3.2. Okay, you have to check the last spacing. That is between water tanker and roof terrace, 3.2. Okay, so typical story height is 3.2. And bottom story height. Bottom story height is the height from ground floor. The height from ground floor to that of the bottom face of footing. The bottom face of footing. But in this case we have a basement floor, so we can deduct basement floor, or your bottom story height is from basement floor to the bottom face of your foundation, and you can check it from soil data. So for our case, your bottom story height is 3.5. That's from soil data. Make it 3.5, and typical story height is 3.2. Total number of story 9. Okay, so you can edit it one by one, our story. So any ETABS, the basement floor is story 1 and ground floor story 2. So make it similar with your architectural plan. So make it story 1 to a basement floor. Okay, sorry. Basement. Okay, basement floor, and story 2 to be ground floor. So first floor, second floor, third floor, fourth floor, fifth floor, roof terrace. Okay, the last one is that water tanker. So okay, check your all your heights or typical all your heights from the architectural plan. So the other heights are 3.2 that are correct, but the spacing between basement and ground is 2.8. Okay, check your architectural plan. The spacing between ground floor and basement floor is 2.8. So make it 2.8. Okay. Ground floor is our NJ, so it must be 0. So make it minus 6.3 at the base level. So ground floor becomes 0, and the last elevation at water tanker becomes 22.4. Okay, have to check it. 22.4. So it's good. And after this, okay, master story. Okay, what's master story mean? I will show it on architectural plan. For example, we have a typical floor that is from second to fifth. If we make a second floor is a master story, the other floor, that means from third to fifth, looks like a second floor, and everything on ETABS that I have to do in second floor is automatically drawn into the other floors that are from third to fifth, because the other floor looks like a master floor or the second floor. Okay, so make it second floor as a master story. Yes, so the other floor that are from third to fifth looks like second floor. So make it second, make it similar with second. Okay, so okay, make it grid only, and okay. At this time, all your grid lines are coming within plan and elevation. So before proceeding to the next step, you have to check all your grid lines if that are similar with your architectural plan. Okay, minimize it. Okay, minimize it, and okay, this is good. So where is the basement floor? Okay, the spacing between A to B is 4.4. That is good, and between B to C is 5.3. 5.3, that is good, and the spacing between C to D is 4.55. 4.55, and the last spacing is 5.3. 5.3, that is good, and in YID, okay, the spacing between 1 and 2 is 6. That is 6, good, and 2 and 3 is 3.85. 3.85, that is good, and between 3 to 4 is 5.45. 5.45, and between 4 to 5 is 5.4. 5.4, that is good, and the last spacing is 2.9. 2.9, okay, that is good. So we can proceed to the next step, that is defining material. Okay, go to define material property. Okay, From here, we have to define two types of material, that is concrete and reinforcement bar. To define concrete, okay, make it or go to add new material and click. So you have to choose a region that is Euro or Europe, because in Ethiopia you have to use European Building Code of Standard that is similar with that of Ethiopian Building Code of Standard. So material type, that is concrete, standard Euro, and grade. Okay, you have different grade of concrete here. So for horizontal and vertical structure, you can choose. For horizontal structure, have to choose concrete grade of C25, that is cubic strength is C25, and this is a cylindrical strength, that is C20 for a concrete grade. This is cylindrical and cubic strength of concrete respectively. So make it okay. At this time, it has by default gives a mechanical property of C25 concrete grade. So at this time, we have to only change the poisonous ratio. This is because on ETABS, on Ethiopian Building Code of Standard, we have two types of concrete, that is cracked and uncracked concrete. So for cracked concrete, you have Ethiopian Building Code PUTUS or Ethiopian Building Code gives a poisonous ratio of 0 and 0.2 for uncracked concrete. So you have to make poisonous ratio of concrete to be 0 for cracked concrete, and okay, make it okay. That is concrete cylindrical strength is Tioni. It's good. It's correct. So make it okay. Okay, damping ratio, you have to use 0.05. Check it from Ethiopian Building Code of Standard. Make it okay. Okay. So I have defined C25 grade of concrete. So for horizontal member of my project, so we have to define C30 concrete grade. So to vertical members of our structure, make it add new material. So region is Europe, that is correct, and material type concrete, standard European norm, that is good, and you have to only change concrete grade, that is C30 grade of concrete, make it okay. So you have to change the poisonous ratio for cracked concrete, that is 0. Okay, make it okay. Reinforcement bar. Okay, reinforcement bar. Okay, add new material. So origin is also okay. Europe, material type, that's not concrete, it's river. Okay, and grade, make it okay. So you have to define by user, make it okay. So mechanical property of steel is coming. So for reinforcement bar grade of 500 megapascal, you have to change some property. You have to change some properties. Okay. Unit per weight per unit volume, that is averagely 73. Okay. So modulus of elasticity for steel, it's not this, it's from Ethiopian Building Code of Standard, it is averagely okay this. So thermal expansion, okay, use it as it is, and so modify. Okay. Now from here, minimum yield strength is Fy, minimum tensile strength is Fu, expected yield strength is expected tensile strength. So minimum yield strength is averagely equal to that of expected yield strength, and minimum yield strength is Fy and expected yield strength is Fye is equal to that of minimum tensile strength is Fu, or expected tensile strength is Fue divided by factor of safety, that is 1.15. So minimum tensile strength is 500 for rebar of 500 megapascal, grade of 500 megapascal, and that is equal to that of expected tensile strength is 500, and expected yield strength is and minimum yield strength is this number divided by 1.15. Okay, that is good. So we can relate number after fourth digit. Okay, make it copy those. Okay. So okay, damping ratio, material damping ratio, that is 0.05. Okay. Have defined a reinforcement bar of 500 megapascal grade. So we have to define both concrete and material. Okay, make it okay, and we can to proceed to the next step, that is defining of concrete section. Okay, we have to define a frame section, slab section, wall section. Okay, first you have to check your architectural plan from the architectural plan. Okay, measure your column section to define column. Okay, it's a rectangular in section. So for 8-story building, you can use any section, and after analysis you have to change it. So define section property, frame section. Okay, so define section property, frame section. There is default settings, default material properties. So make it delete up to okay, make it delete all and add your own material. So okay, delete a multiple. Okay, choose all or select all. Okay, delete all selected frame. Okay, select all, delete all selected frame. Okay, make it okay. So add new property, concrete. Okay, choose concrete rectangular. Okay, that is concrete. So make it column 50 by 30. Okay, 50 by 30. So material, that is 4 column use C30, and okay, national size data auto. Okay, make it okay. So you can change the color. Okay, choose okay, this color for column, make it okay. So you can add some note here for column 15 by 30, that is C30 concrete grade. Okay, section shape concrete rectangular. Okay, that is good, concrete rectangular, that is selected before. So depth, that is 500 and width is 300. Okay, so you can okay, this is a modifier. We can go back to we can go back, and I have to define all this data later. So modify okay, modify. So I have to modify a column. So okay, select column here, and it's a rectangular and okay, confinement bar, that is straps. So reinforcement to be checked, reinforcement to be designed, that is a reinforcement to be designed, and concrete cover, that is calculated, it's good. So make it as 40 mm. So number of longitude number, okay, you can add number of bar, but it's to be designed. So longitudinal bar size, make it 16, or corner bar size, make it 16. Okay, you can use it as before for confinement bar. Okay, 8. So make it okay. So I have defined column section of 15 by 30. So 50 by 30. Make it okay. Okay. Add new property. Sorry, you can choose. Okay, add a copy of. So column 55 by 35. Okay, make it C30. Okay, you can choose. Okay, similar color. So it is 55 by 35, and all other. Oh, sorry. So rebar type must be selected, that I have to define, that is R500. Okay, so all the other data are similar, so make it okay, and I have to return back, modify. Okay, modify. So rebar material must be S 500 megapascal. Okay, make it okay. Make it okay. So add one material, that is okay, for column for the upper part. So add a copy of, okay, column 14 by 30. Column okay, so use similar color. Okay, rectangular, that is 40 by 30. Okay, so that's good. Make it okay. For beam, okay, add new property, or you can use you can start from your column definition, that is add a copy of. So beam 400, beam 40 by 25. So make it C25, and can choose color. Okay, it's concrete rectangular, that is its depth is 400. It's good, and its width is 250. So the only difference is that it is here. So make it beam, and cover to longitudinal. Okay, color from the centroid of your bar. Okay, so this is equals to 30 plus your staffer diameter, that is 8, plus half of your main bar, that is 16 divided by 2, that is 8. Okay, so 46, make it 45 averagely. So copy. Okay, this is good, so make it okay. Okay, okay, add one material that is for water tanker beam. So use add a copy of beam 14 by 20. Okay, its color is also this, so 20. Okay, the other property similar, so okay, so our frame section is defined, and you can add properties later. So we have to define your slab, slab property. So you can use this and edit it. Okay, modify show property. So slab 160. Okay, its grade is C25, and it's 18 shell. It's 18 shell. So change color. Okay, it's good. Use this color. I can add some now. Okay, that is 160. Make it okay. Okay, add a copy of, so slab 150 for water tanker. Okay, make it only this 150. So 150. Okay, make it okay. Make it okay, and you can define slab for your staircase. Define slab section. Okay, so add a copy of make it a stair for a landing slab, that is under okay. Okay, choose this color. Okay, for a staircase, make it okay. Okay, so you have to define also wall section for shear wall, shear wall for basement floor, and for your elevators. Okay, make it wall. Okay, modify wall 200. Okay, so this C25. Okay, make it C30. Vertical. Okay, 30. It's 18. Okay, it's 16, but it's if it's above 250, it may be a shell thick. So make it a shell thin, and change the color. That is, you can change any color. Make it this. Okay, and it's 200. Sorry, make it okay. Okay, so all your material, you have to draw your grid lines. You have to define all your materials, and you have to define frame section, wall section, and slab section. That is good. Okay, it's enough for today. In the next part, we have to go to model your building. So subscribe my channel to get more video about this project and other projects. So thank you.